Okay, so this lab that we're going to be doing today is tracking the sun across the sky. Tracking the sun. Now, if you want to study how the sun moves across the sky, one way you can do that is by looking at the sun, all right? However, that's a dangerous way of doing it unless you have proper safety equipment. Another way you can do it, which is much easier and less dangerous, is by studying the sun's shadow and making measurements of the sun's shadow. Because if the sun is high in the sky, then the sun will cast a shadow like that. All right? If the sun is lower in the sky, then the sun would cast a shadow like that. All right? So when the sun's high in the sky, it casts a short shadow. When the sun's lower in the sky, it casts a longer shadow. And you could actually calculate what the altitude of the sun is based on the length of the shadow. If I know the length of the shadow and I know the height of the stick, I can actually calculate what that angle is too. But we don't need to do that for this lab. All right, so I can determine how high the sun is in the sky based on the length of the shadow. Sun's higher in the sky, shorter shadow. Sun's lower in the sky, longer shadow. So like in the morning when you're first getting up and the sun's nice and low in the sky, you probably notice that your shadows are really long. When it gets to be around noon and the sun's higher in the sky, you get shorter shadows. And then in the evening when the sun gets lower again, you get longer shadows again. All right. So how long the shadow is tells me roughly the altitude of the sun. Another thing I can tell is the direction the sun's in. Because whatever direction the sun is in, the shadow is going to be in the complete opposite direction. So if my shadow is pointing to the north, that means the sun is directly south. Right? If the shadow is pointing to the east, that means the sun would be directly in the west. If the shadow is pointing towards the southwest, that means the sun's in the northeast and so forth. So the direction of the shadow is always going to be the complete opposite direction of the sun. So I can tell the altitude by the length of the shadow, and I could tell the azimuth or direction by the fact that the sun's going to be the opposite direction of the shadow. All right. So that's basically what you're going to be doing at the lab today. So on today's lab, okay, long story short, it says on a clear fall day, the sun was tracked across the sky by using a setup similar to the one in figure 2. The sun shone on a pencil, producing a shadow on the cardboard. As the earth beneath the cardboard rotated to the east, the shadow changed each hour. All right. So I have a piece of cardboard right there, a pencil was put in it, it was put outside, and then the shadow was cast by the sun. And during the course of the day, as the sun moved, the location of the shadow moved, and where the tip of the shadow was recorded. And that's what this data is right here. So it tells you what time, and it shows you on that paper where the tip of what are the coordinates of the tip of the shadow. All right. So it has it from 8 o'clock in the morning to 2 o'clock in the afternoon. All right, so what you're gonna have to do is, you're gonna take this data and you're gonna graph it on the next page. So the graph looks like this. Now, first off, just to point out, there's something really peculiar about this graph. On the side, it says x-axis, and on the bottom, it says y-axis. Why they did that, I don't know, but that's just how they did it in the lab. All right, so first off, you're going to have to number your axes. You have to number it by ones, so each line goes by 1. You don't necessarily have to write each number down, but each line has the value of 1. So I can go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. All right, so there's my numbers on the side. Same thing on the bottom. So it's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, and so forth. All right, next what you're going to do is that data that was in the data table on the previous page, you're going to plot those points for the tip of the shadow, and then you're going to label it. So for the 8 o'clock time, it says the x value is 29 and the y value is 2. So you go x value 29, y value 2. So I put a dot right there, and I label that 8 o'clock. And the next one, 21:15, x value 21, y value 15. It's right there. I make a dot, label that 9 o'clock, and so forth, and do one more. 17 and 23, 17 and 23, about there. 10 o'clock and so forth. So roughly speaking, like you have like 11, 12, 1, 2. Next you're going to plot the position of the pencil location, which is 131. Label that pencil. Then what you're going to do is you're going to recreate the shadows. So you're going to need a straight edge, and you're going to connect the 8 o'clock to where the pencil was. So that represents the shadow at 8 o'clock, because that's where the pencil was, and that's where the tip of the shadow was pointing. Then you're going to do that for 9 o'clock, 10 o'clock, 11 o'clock, 12 o'clock, 1 o'clock, 2 o'clock, and so forth. And then what you have to do is you have to measure the lengths of those, and you're going to put the lengths of those in the data table. Now, the last line in the data table where it says pencil shadow length, pencil shadow, don't worry about that one because there's not going to be a distance between the pencil shadow and itself. And then you just got to answer the questions based on the graph that you made and your data. And that's it.